You may be great at mathematics, or it might be one of your weaker subjects. Wherever you stand, it is possible to improve your marks considerably in the final exams. Hi, I'm Arjun Bhagat, your personal guide to achieving success in the exams. So join us for a very special session of practice questions, insider tips, advice and guidelines tailored especially for you, because at Topper, we help you study smart so that you can score smart.
Today we will be focusing on chapter Continuity and Differentiability from the unit Calculus, which carries a whopping 44 marks in the board exams. That's almost half of the total paper, and therefore it's extremely critical that you spend a lot of revision time on it. Besides revision, it will also help you to know what kind of questions you can be asked. The unit Calculus has 5 chapters in it: Continuity and Differentiability, Application of Derivatives, Integrals, Application of Integrals, and Differential Equations. Since we are discussing only continuity and differentiability today, let me begin by telling you that you can expect 2 questions worth 4 marks. Now you can expect 1 mark very small answer type questions, as well as 4 mark short answer type questions. You should also be prepared for 6 markers long answer type questions.
It's good to know the trends, but what are the special raw materials that you need before you begin preparing for the exams? Well, there's only one way to find out. Let's check out the key concepts of this chapter in recap.
Under the topic Continuity and Differentiability, you should be familiar with the following: continuity of a function at a point, continuity of a function in an interval, differentiability, derivative of some basic functions, differentiation of composite function, chain rule, differentiation of parametric functions, differentiation of a function with respect to the another function, mean value theorem, Rolle's theorem.
As you've seen from past year trends, this topic is very crucial. You just cannot afford to underestimate how important this topic is when it comes to the board exams. But don't worry, even though this is a critically important chapter, there are many ways you can maximize your results. Well, one way is by specifically honing abilities required for this chapter. Let's take a look at Knowledge Tip.
Get ready to sharpen not 1 but 3 of your abilities, namely knowledge, conceptual, and numerical abilities. While most of these questions from this unit are based on conceptual and knowledge ability, you may get some questions that test your numerical ability. Besides ability types, you should also be aware of important subtopics which appear regularly in the exams. These are on the continuity of a function at a point, questions based on Rolle's theorem, differentiation of a function with respect to another function, differentiation of parametric functions, and second-order derivatives of a function. In some years, questions on the mean value theorem have also been asked.
If you're set with your tools, it's time to rev up your engines and accelerate at top speed and answer exam questions.
It is given that a function fx is continuous at x equal to 1. We have to find the value of constant k. This knowledge ability question is based on the continuous function at a point and is 4 marks. Just by looking at the question, we can tell that the left-hand limit is equal to right-hand limit at 1, which is equal to f1. Since a function is continuous, at x equal to 1. Write this mathematically and you earn 2 marks. So, we find the left hand and right hand limits at x equal to 1 and then finding them equal to each other, we find that k is equal to 4. Take a look at a similar question based on continuous functions that was asked in 2008.
Wasn't that model question easy to solve? In fact, it reminded me of a maze whose twisted corridors lead to the prize at the center. Just like the maze holds the pathway to the prize within itself, the same way this or any other exam question you face holds the solution within itself. All you need to do is to read the question carefully and find the clues hidden within it. On that note, let's head straight into our next segment. Practice makes perfect.
In this question, we have to find all the points of discontinuity for the given function. To find the points of discontinuity, we need to first find those points where left-hand limit is not equal to right-hand limit, or if the two are equal to each other but not equal to the function value at the point. Before x is equal to 1 and between 1 and 2, fx is a polynomial function, so it is continuous. After x is equal to 2, fx is a constant function, so it is continuous. Now, at x equal to 1 and at x equal to 2, the function changes its nature. So, we should check the continuity of the function at point x is equal to 1 and 2 only. This is a very important step, so you must emphasize and highlight it. So, to test the continuity of the function at point x is equal to 1 and 2 only, we check the continuity of the function at x is equal to 1. We calculate the left hand and right hand limits at x equal to 1, also f1. We find that the left hand limit is equal to 3 and right hand limit is equal to -1. Since the left hand limit is not equal to the right hand limit, the function is discontinuous at x equal to 1. For this step, you earn 2 marks. Similarly, for a equal to 2, we find the left hand limit and right hand limit at x equal to 2. We find that the left hand limit, right hand limit and f2 all have the same value, which is 0. So the function is continuous at x equal to 2. You can deduce that the only point of discontinuity of the function is x equal to 1.
Remember to state your final answer clearly in the end. Don't assume that the examiner will hunt for it in your solution. Next, let's take a look at a numerical question which has been asked in previous exams and is likely to appear in the upcoming examination as well.
This question requires you to verify Rolle's theorem for the given function. It is a 4 marks question which appeared in 2006. Here we have to verify Rolle's theorem for the given function fx. We know that all polynomial functions are continuous. And here, fx is a product of 2 polynomial functions. So, fx is continuous in the closed interval 1, 2. Now, differentiating the function fx with respect to x, we get x minus 2 into 3x minus 4. This exists in the open interval 1, 2. So we say it is differentiable in open interval 1, 2. Your answer till this step will fetch you 2 marks. From the previous calculations, we know that there is at least one point C that belongs to the open interval 1, 2, such that f-c is equal to 0. On solving it, we find C is equal to 4 by 3 and 2. Of the two, 4 by 3 lies in the open interval 1, 2. So we find that Rolle's theorem is verified for the given function f(x). You should be very careful with this solution because it is frequently asked. In fact, a similar question based on Rolle's theorem had been asked in 2007.
It's time for our Exam Express to make a brief pit stop. But don't go away because there's lots more coming up. Practice questions, today's HOTS question, and of course, the all-important tips segment to give you that extra edge. So while we take a short break, why not keep your engines warm by solving this breaking question?
You should solve this quite effortlessly. It's a conceptual ability question based on differentiation of a function to infinite series. The function y of x is given by root log x plus root log x plus root log x plus and so on. You have to find dy by dx. If you get this right, you won't just earn 4 marks in the final exam, but you'll also be this episode's brain teaser champion. So get cracking! Before the break, we asked you to solve a question based on differentiation of a function to infinite series. The function y of x is given by root log x plus root log x plus root log x plus and so on. Find dy by dx. Observe the given problem carefully. If we leave the first expression, the rest of it is also the given function y. Now, the function will become y is equal to root log x plus y. On squaring both sides, we get y square is equal to log x plus y. Next, we have to find dy by dx. So we differentiate the whole equation with respect to y. On solving it, we get dy by dx is equal to 1 upon x into 2y minus 1.
Welcome back. I'm Arjun and I feel quite confident that you've cracked the breaking question. But before we proceed further, let's see what we learned in the previous section. Now, the most important thing that we learned was that this chapter is critical for the upcoming exam and that it can't be taken lightly. We then solved problems based on the points of discontinuity, Rolle's theorem and mean value theorem. Now ready to restart our engines and pull out of our pit stop? So here's our next practice question.
This question tests your knowledgeability as you need to identify the requirement of this question and relate it to finding first and the second order derivatives. Here, function y is equal to sine log x is given. we have to prove that x square d2y upon dx2 plus x dy upon dx plus y is equal to 0. For this proof, we first find the first order and second order derivative with respect to x. So let the given function y is equal to sine log x be equation 1. Now, when we differentiate equation 1 with respect to x, we find dy upon dx is equal to cos log x by x. Name this equation 2. Once again, differentiate equation 2 with respect to x. We find second order derivative d2y upon dx square. Now, by using equation 1 and 2, we find that x square d2y upon dx square plus x dy upon dx plus y is equal to 0. This is the complete answer which will earn you 4 marks. Take a look at a similar 4-mark question that is important from the exam point of view.
Now let's take a 4-mark question that might possibly appear in the next exam. It is based on your conceptual ability to use your understanding of parametric differentiation.
In this problem, x and y are two parametric functions in theta, and we want to find the value of second order derivative at theta equal to pi by 2. For finding the second order derivative, first we need to find the first order derivative dy by dx. As you may have already figured out, x and y are the functions of theta. So, we differentiate both the functions with respect to theta and then find dy by dx. Now, d2y upon dx square is equal to 1 upon 2 cosec square theta by 2 into d theta by dx. By using equation 1, we insert the value of dx upon d theta. Upon solving it, we find 1 upon 2 cosec square theta by 2 into 1 upon a into 1 minus cos theta. Since we have to find the value of d2y dx square at theta equal to pi by 2, so we put pi by 2 in place of theta. We find 1 upon a, which is the required answer.
With that, we've reached the end of our practice questions. I hope you made special notes of them, since many of them have proven to be great favorites with the examiners over the last few years. Now, revision and hitting the books is of course essential to achieving success in the exams. But as you read and reread the concepts discussed above, do remember to take care of your health. Don't let the stress get to you, eat your meals on time and get plenty of fresh air and exercise. Remember, only if your batteries are charged will you be able to meet a HOTS question requirement. That's right, get ready for some high-order thinking skills.
A HOTS question is a recent addition to the exam paper by CBSE and is essentially a conceptual ability question that may not be very familiar to you. Here you need to be thorough with the differentiation of implicit functions. Read the question carefully and examine what is given to us. Try and come up with an appropriate substitution. The question is, if root 1 minus x square plus root 1 minus y square is equal to a into x minus y, then prove that dy by dx is equal to whole root of 1 minus y square upon 1 minus x square. You could try and solve this by direct differentiation, but that would cost you a lot of precious exam time. There is a shorter and simpler way to solve this. Just put sine theta for x and sine pi for y. After solving it, we find theta minus pi is equal to 2 cot inverse A. Now, again put the values of theta and pi in x and y. We get sine inverse x minus sine inverse y is equal to 2 cot inverse A. On differentiating with respect to x, we get the required answer dy by dx is equal to whole root of 1 minus y square upon 1 minus x square.
What this HOTS question required was some lateral thinking. Of course, you could have used more conventional methods to solve it, but that would have taken a lot of time and energy. If you're looking for more tips like this, log on to our website www.topperlearning.com, or you could also dive straight into our next segment, Topper's Special Exam Tips.
Here are some tips you can use to avoid mistakes. Finish your paper on time and keep the examiner happy. For a function to be differentiable, make sure that it is continuous at that point, because a function cannot be differentiable if it is not continuous. If a function changes at some points, then check the continuity or differentiability only on those points. When doing a question on continuous functions, differentiation of parametric functions or second derivatives, etc., make sure you write the basic formula at the beginning of the solution. When doing a question on Rolle's theorem or the mean value theorem, make sure you have written the conditions clearly and distinctly, so that the examiner doesn't need to search for them in your solution. Before finding the derivative of a function, simplify it and bring it to a stage at which it is easy to differentiate the function.
It's time to wrap up today's exam special and say goodbye. But before I leave, I do want to emphasize how important it is to maintain a balanced approach to your preparation. Don't forget, relaxing is an important part of the Topper strategy to studying smart. So take care and goodbye.